Okay, so since I haven't received any questions from you regarding what we did in the past, I'm just going to continue. I said that we are basically going to continue with double integrals over general regions. That was what I said the last time. Good. So I'm looking at double integrals over general regions. That means that I'm looking at regions different from the rectangular region that we discussed the last time. I am basically looking on the chat section, so if there are questions or anything pops up, I can attend to them. As it stands now, I'm only sharing the textbook, and I'm not sharing any other screen, but I will use the Jamboard with time to be able to explain a few things. So I have my Jamboard open, and then I'm going to use it, but I want to use the pictures in the textbook. So instead of showing them in my slide, but I'm going to upload my slide for those of you who would prefer a more summarized note than what the textbook is presenting. Okay, so if we basically want to look at what we did the last few times, was looking at integrals, iterated integrals, and then Fubini's theorem on the fact that we can always change the order in which we do our integrals. And if we change the order, or when we are presented with an integral, we would want to look at the easiest or the best way in which the integral can be done. But there are times where you have a situation that it doesn't actually fit into what we have learned so far. That is, we are not working over a rectangle, but we'll be working over either general regions, such as areas bounded by curves. So I'll use the figure here to explain the first ideology of what I intend to explain with that. So I'm looking at figure 14.11. That is this figure, which I want to zoom into. So assuming I have an integral to work on, it's a double integral basically. So if it has a function, then I know I'm working on the volume. If it doesn't have a function, then I know I'm basically just dealing with the area that is described here. So there are three possibilities. There are basically three possibilities. Assuming I have the region bounded by the curve G and then the curve H. If I do have this, then what I want to do is I can rewrite the integral. I can rewrite the integral such that I have the limit of a to be what the limit of x to be between a and b, while y will be bounded by g and h. So I'm looking at a situation. I need to just project that where you have x being bounded between a and b. Stop sharing this and then share this. I'm sharing my entire screen now for the mere fact that I want to be able to do this. So let's just look at a case where and y is equal to h of x. Okay, so if I have this situation, then I can write this. The limits of the integral as what? A less or equal to x less or equal to b, and then y is bounded between g of x. So let me see which one comes first. G is down. I'm not sure. There's something just not right, my system. Okay, so I have g of x less or equal to y less or equal to h of x. Good. So if I have this situation, my goal is to find this integral over a certain region, but I know R is bounded by what? The graphs y is equal to g of x and then y is equal to h of x. If I have this situation, then from the graph, that is this, I'm looking at the first part. Because I have the situation, then it means along the x-axis, x is between a and b, and that is why I wrote this. X is between a and b. However, along the y-axis, so I am looking at, if I take this to be the breadth, then the height, or if this is the length, then the height here or the breadth will become what? The region bounded between this graph and this graph. So y starts from g of x and ends here. That means that this double integral, which I am about to evaluate, can be written as what? Therefore, the double integral becomes this. I integrate from a to b, then I integrate from g of x to h of x. The same function, so the function would change, the same function, but this time I have to do dy before I do dx. So with regard to the very first figure, what happens is that I would have to arrange the order of the integral this way. The reason is that if you integrate first with y and you use the endpoint or the limit of y, the resulting integral becomes a situation where every function or everything else looks more like an x variable for you to do. So after the first integration with respect to y, you would have a situation which looks just where you basically have to deal with a function or a function that solely depends on what? On x. So you would have a situation such as this. So you would have this, which I'm going to just copy and replace that. You have this situation where you are integrating basically just with x. But now this function becomes h of x minus f of x, comma, g of x. Oh, sorry, we don't need the y again. So I am not watching the chat screen. If somebody has a question to ask me, the person will have to speak out because I'm not watching the chat screen at the moment. Good. So if you do the inner integral, that is, you integrate with respect to y, you have a resultant function, and you would have to substitute the value of or the expression for hx and gx back into the function. So you have something that looks like it. And now you have an integral to do solely with respect to what? With respect to x, because you would have integrated with respect to y, and you have this integral to do. And by the time you are done, you will actually have a result which looks more like. Do I need to listen to somebody? Okay. So now you have this integral to work on. I can decide to put an equal to sign there. You have this integral to work on. Good. Let's look at it, the other one. What happens if you have this? If you have a graph where the two curves h and g intersect, and then they do not intersect again here. What you do with this is you find the point of intersection, the common point of intersection right here. That becomes the a value. And then b is from here, but again, the integral will be from what? G of x all the way to h of x for y. Then x is between a and b. And the third case, so I think this is the most general one. If it happens that the graphs do intersect, then you equate the functions and solve. And this is something you might have seen when you are finding the area between two curves. The only difference in multivariable calculus is that you have an extra function to work on, not just the area. If it ends up that the graphs actually do intersect, where you can basically find the 2 points of intersection, then those will become the x values, while the y will still integrate from what? G of x to h of x. So this is one scenario if the graphs or the functions are expressed as what? Y is expressed as a function of x. The reverse is also true, where the function is such that it is easier for you to write it as what? X is a function of y. So if x is a function of y, which I think the book discussed later on, let me look at the reversing of the order. This is a case where, so looking at this, we are writing y as a function of x. But what happens if the graphs are different, where it is easier for us to write it as a function of what? of y, then we would have to look at that situation. So I'm going, I will talk about the examples later. So change of perspective, I think that's how the book calls it. Good. So in this case, what is happening is we are looking at a situation where the region we are interested in is bounded between a curve that is written as what? X is equal to g of y, and the curve that is written x is equal to h of y. So in this case, what happens is that you rather put or fix the values on the y-axis. So in this case, you would be writing this. I'm going to basically copy this and then rewrite it. So if, however, the integral is given as this, where r is bounded by this. So in this case, you have x a function of g of y, or it's a function of y. And then x, again, is a function of what? Of y. Then we rather fix the values of y up to d. So I take it from c to d. And then you integrate, x will be bounded between the functions g of y and h of y. So you have something that looks like this. Good. So let me just put a space there. Space 5 minutes. I want to develop a vertical space. So good. Good. If, however, the limit is given, so I've just increased, like just basically to separate it. So if, however, the integral is given as this, where r is this time bounded between a function g of x and g of y, and then h of y, then we would have to rather fix what? The value of y, that is between c and d, while we integrate, we keep the limit of x, because x is bounded between g of y and this, so you rather place the boundaries of x here. And that means the order of integration will have to change. You integrate x first before you integrate y, because y has the values. Does that make sense? So depending on the region, and which one is very easy for you to do. So you see, you are given a situation where you have to think about what is the best way to describe the region. Is it easier for me to write it as a function of x or as a function of y? And depending on which one you have, that would determine the order of the integration. In this case, the order of the integration will be given as this. So you rather integrate from c to d for y. g of y to h of y. And then the order of the integration changes. So you integrate with respect to x first before y. So in this case, the integral is evaluated as follows. So you integrate x before y, and x takes what the function from g of y to h of y. That is basically what this is telling you. So it means moving along the x-axis, you start from g of y and end at h of y. But moving along the y-axis, you integrate from c to d. And it's the same thing. If the graphs intersect at one point, you solve the simultaneous equation to obtain the point of intersection, and then you fix this boundary. If they have 2 points of intersection, then you can actually will have to solve. By the time you finish solving the simultaneous equation, you'd have obtained the two. This is a situation where you can easily do these integrals depending on how the graphs look. So we are going to look at two different examples, which I think will fall into both categories. So let's look at this example one, which basically talks about the region. What I'm going to do is I'll plot the region for you to see. I'll have to plot those figures for you to see which one is which one. And I'm going to use, again, I am using a software to do the plotting, but it's something you can easily see. That is, if I take the two graphs, so in this case, we want to be able to evaluate the function this. As an example, evaluate this. As an example, evaluate this, where I have 2 yx squared. So y is 2 times y times x squared with respect to a. Where r is bounded by y equal to 3x squared and y equal to what? I think 16 minus s squared. Just check. Yes, y is equal to 3s squared and then 16 minus s squared. I would plot this for you to see, even though there's an indication in there. It's easier for you to just get a glimpse of it. Good. So we have this situation. As an example, evaluate this, where R is bounded by this and this. The first thing you have to think about is, how do these graphs look like? How do these graphs look like? So this, if you think about this, 3x squared is definitely going to face upwards. while 16 minus s squared will face downwards. But do they have a point of intersection? So I'm going to sketch these graphs, and then I'm using Maple to sketch them for you to see. I know you start asking if you have to sketch every graph or everything to be able to see. I don't have a straightforward answer. Sometimes it's easier to see. I can just equate those two graphs, but it's better if you sketch to see. If you understand it, obviously I know how this will look just because I know this will face downwards. So it depends on you working with functions and knowing how the functions look.
Sir, I have a question. Respect to x squared, how would you, sir?
Yeah, I'm listening. I'm listening.
Yeah, how would you know where the curves, like the one of x squared, how would you know where it directs to?
If you
Upwards or
have s
downward?
squared, how would you know how it looks? Is
Yeah,
that
on
the
the graph.
question?
Exactly.
Yes. No, x squared. S squared will always face the positive y-axis because if you look carefully at x squared, y will always be positive for every value of x. If you take negative x and you square it, you get a positive value, right?
You take negative x,
If you take negative 2 and square it, what do you get?
you get negative 4.
No, that's
Get
not true.
4.
You can't square negative 2 and get negative 4. You get positive 4.
No, 4. I said 4. 4.
Yes, so that means that is a positive value. So it means definitely that graph will look upward.
Okay.
So let me plot the x squared for you. You want us to look at x squared. I will still come back to this because I know it's important if you get the graph right. So I'm plotting from negative 3 all the way to positive 3.
Okay. But apart from that, for all polynomials, if it actually, example for x cube as well, will you also go upwards on the graph?
S cube is an odd function. So s cube would, you see, this is s squared, and it looks like this. You see, s squared looks like this. S cube is an odd function, so it means I'm using a knowledge you'd have acquired in Math 1. If you're taking Math 1, you would have dealt with types of functions. Math 1 would have dealt with a lot of functions, so you'll be familiar with functions. X cube is an odd function, so it will look more like an integral sign to switch from the positive sign and go to the negative sign. So let's plot s cube. Yeah, this is how it will look. Is that okay?
Yes, sir.
Good. Okay, so let's go back to what we want to do. We are doing 3 times s squared. 3 times s squared. And then 16 minus s squared. So these are 2 separate graphs that I want to plot. So I do this. And let me see what happens. I will change my limit of integration with time. Error missing operator. Oh, sorry. Good. Good. I have a graph that looks like this. What it actually tells me that even the 3 is too much. I've gone let me see what happens. I think they intercept at 2. So let me see. So this is 2.5. Good. So this is okay for me. Let me just enlarge the graph. Good. This is how these graphs look. There is a point of intersection and a point of intersection. So this somehow looks like my very first one, the first part of the graph that I spoke about. Where is 11 point? Good. Now the third one, I think it looks more like the third one. It looks like this, right? It looks like this. So you have this sort of graph. And once I have this sort of graph, it clearly tells me that I will have to solve this simultaneously. I'll have to solve this simultaneously. So now I don't have a choice but to go to my my Jamboard and see how I'm going to struggle writing on that thing again. Let's see what happens. Or I can still stick with my solving. So now I have to solve this. 3x cubed is equal to what? 16 minus x squared. And this gives me something. So I have to solve this. So what do I get? Right from this equation, this is equal to that. I want to find a point of intersection. This is equal to that. So when I move the x squared here, it becomes 4x squared, right? So it gives me this situation. 4x squared is equal to 16. Which I can write as what? X is equal to negative 2, comma 2. So these are the possible values, negative 2 and 2. And this should be obvious. Is that true? Because I'll divide through by 4, so I have x squared is equal to 4. And that means x is negative 2.
Yes. Plus or minus 2.
Thank you. Therefore, we have what? Negative 2 less or equal to x less or equal to 2. And then y will be between I'm not sure what is wrong with my system today. Okay, so y will be between 3x squared less or equal.
Sir, please, I have a question.
Please ask. Please ask.
Sir, please, what if they are not meeting? Do you have
What
to
if
get the values?
what if they are not meeting? Then there will be an extra condition that tells you maybe you would definitely be able to figure that out. So I'll look
What
at
if the two curves are not meeting? How will
what
you get the
if the two curves are not meeting. There will be an extra information that tells you how what you should place the restriction on. Is that okay?
Okay, sir.
Yes, there will be an extra information.
Okay, sir, thank you.
As a matter of fact, I just picked this question from the, as an example, I did not even look at the extra conditions. I basically look at, so I am doing this which is bounded between that. I've not looked at the extra condition that is given. I think that is example one. Let me just see. I don't know what extra condition is given. I don't think they give any extra condition. Yeah, it just said as an iterated integral where R is the region bounded by the parabolas this and this, then evaluate the integral. And basically it just went on to tell you that what you should do, solve this and then find that, and then it gave you the value. Good.
Okay, sir. Thank you.
Yes. Then you looked at something else. So don't worry, I'll go to what I normally do with my classes is I solve one example in the textbook and then I pick an exercise from the textbook, something that you should try. My goal and the reason why I teach this way is this. So I know this is the first time I'm teaching you. I teach using my textbook. The reason is this. You should go back to textbooks. You are an engineer or you are learning to become an engineer, and it means that you are not limited to the information the teacher gives you. So I normally teach using textbook. I tell you I'm using this section of the textbook, this section of the textbook, and then I will summarize that into my slide. So you come to my lecture, you have a slide or you have a note, but then the example you see, one is from the textbook as an example discussed in the textbook. One is an exercise from the textbook. And then when I'm going to give you exams, definitely I'm not repeating those things. I would give you a problem. I can lift an exercise from the textbook for you to do. And the reason is I expect that you have gone through the textbook to expand your knowledge on whatever I've given in the lecture hall. So basically, I am not only going to ask you to do what I have, or the example I have covered in class. I'm not sure how your Math 1 and 2 was presented, but I expect my students to have a wider knowledge in the field because, as a matter of fact, this is just a tool for you to solve other problems with. So my goal here today is when I'm done with this class, I'm expecting that students will have understood that if I have to do a double integral over a region which is not a rectangle, then I must look at how the curves look and then choose whether I will be integrating, I'll fix the values on the x-axis while I leave the functions for the y-axis, or I'll fix the values for the y-axis and then allow the functions to vary along the x-axis. So that is my goal. At the end of this class, I expect that will be understood. You'll concentrate on which regions am I supposed to do the integration on, and how does that region look, and how do I write the limits of my integration. Please remember, this class is not about teaching you techniques of integration. It is about how to write your limits such that you stay within the region you are considering. When I move on, I can describe that this function is about dissipation of heat. If heat is being dissipated in a room or in a particular cylinder or in an object somewhere, how far will the heat go? That is the limit. The limit restricts you to how far you are going. So this, it's purely about you writing your limits to define the region. Thank you. Where am I? 16 minus x squared. This is something I would have written on, what's it called? On the marker board if I was in class. Less or equal to this. Good. So we have this. It's now I'll have to explain why I am integrating from 3x squared to what? Along this. Why am I integrating from 3x squared to 16 minus x? It's because of the graph I got. So look at this. Along the x-axis, this is along the x-axis. I'll move from where? Negative 2 to positive 2. Along the x-axis. I'm from negative 2 to positive 2. But along the y-axis, I'll start from this curve before I get to this curve. So does it make sense? I'll start from the 3x squared and go up. You move in the positive direction of the y square. You get to this curve before you get to this curve. Is that okay?
Yes, sir.
Shall excuse me.
Good. So along the x-axis, there are two things I'm looking at. The movement along the x-axis. Along the x-axis, I'm just moving from this point to this point. That's -2 to +2. But along the y-axis, if I am here, I'll start from 0 and end at what, 16. But what happens if I'm somewhere here? I'll start from this curve and end on this curve. Right?
Yes, sir.
Good. Let me do something here for you to see. Assuming I have this graph, can I draw a straight line here on the line 4? Can I do this?
Yes, sir.
I can draw a straight line here, right?
Yes, sir.
So if I draw this straight line here, I can define a new region right here. So assuming I ask you to find the region bounded between the curve, this and this, and the, what's it called? The plane or the line x equal to 4. You realize I'm defining this region, but not any other region. And in this case, what is happening is x will start from 2 and end at 4, but the curve will start from where? The 16 and end at where? The 3x squared. In this region, the 16 is lower than the 3x squared. The 16 minus x squared is lower than the 3x squared. So your region of integration would have changed. If I want to concentrate on this region, the limits would have changed. So I'm going to discuss my other example using this. That is just to explain to answer the question, what happens if you have one side or the curves do not intersect? What do you do? And here, moving onwards, the curves here will not intersect. So I must put a boundary on where I'm going or what I need you to do. I need you to just integrate from x starting from 2 up to x equal to 4. And this actually fits into the, I think, the second case where the curves intersect at one point but do not intersect at the other point. But let's solve the one we are working on now before we start thinking about other things. You need to get this before you think about other things. Good. Therefore, we have this situation. Now I have to do this. Begin align.
Dude, can you please turn off your mic?
Me or someone else?
No, someone else. Someone else.
Thank you. So this integral becomes integrate from -2 to +2 let's go. So integrate from -2 to +2, then again integrate from 3x squared all the way to 16 minus x squared and we're integrating 2yx squared. So we'll do dy dx, and this will be equal to something else. Okay. Now let me put this. Let me put the function in a bracket. Just and I want to trick Maple to give me a bigger bracket. That's all. I might not even need that because of S squared. I don't think I need this because of S squared. Good. Yeah, perfect. So we have this, and this is telling us that what we should integrate with respect to y, put in the limits for y before we do x. So the next integral becomes what? We'll integrate. Why don't I just copy this? Maybe it will pop up. To 2. Then I have left this and right that. What happens there? I have what? X squared y squared, because if you integrate y, you have what? Y squared, 2y squared over 2, so the 2's can cancel out. So I have x squared y squared, and then now I'll have to do what? Evaluate my 3x squared, and then the 16 minus s squared. Let me see how this looks. Perfect. So my dx symbol is missing. I need, because when I'm done, I have to integrate with respect to dx. So let me just keep it dx. Good. The other thing I can do to make left right. Good, good. So I have this situation, and this is perfect for me. So I have a situation where I have just integrated with respect to y. And when you integrate this with respect to y, you're going to get what? Y squared x squared, or x squared y squared. Now I have to replace the values, what's it called, of only x. Another thing you can do is you can pull out the x squared, because x has absolutely nothing to do with the y. I can pull out the x squared for maybe an easier representation. I can still pull out this s squared and put it right here. I can do this. And yes, I can do this, which means that I'm only going to evaluate what? 16 minus s squared all squared minus what? 3s squared all squared. And then this gives me this integral. So I'll copy the integral and then just evaluate. Copy this. And just help me not to make any mistakes with this. Good. I'm going to have a situation where I have what? Open bracket 16 minus s squared all squared minus open bracket 3x squared all squared. Good. then it means that I have evaluated this, so I don't need this again. Let's run this and see what the output is. Good. So I have this situation. The y squared, so 16 minus s squared, all squared, and then 3s squared, all squared. So I'll have to simplify this before I do the next integration. So I'm going to, you can actually do this by hand. You can simplify this by hand, but I'm going to use Maple to just simplify it so I get an easier way around it. So I have s squared times this whole bracket, and this bracket is made up of two smaller brackets minus 3x squared all squared. And in this bracket, I have 16 minus s squared all squared. Yeah, that's perfect. Simplify, sorry. Asking Maple to simplify this for me. And then I end up getting what? I end up getting minus 8s squared, x to the power 6, minus 3x, 32x4 plus 256s squared. And that becomes what I need to integrate. So I have minus copy. And I'm integrating this, but within this bracket now, I have minus 8x6 minus 32x4 plus 256x squared. Something is missing. It's not going to come out well. I know. Yes, it will not come out. Perfect. That is it. Minus 8x6 minus 32, and then this. Is that not the figures we got? I think those are the figures. Minus 8s squared minus 32 plus 256s squared. Perfect. Yes. So now I have to integrate this from -2 to this. And then my final result will become what? So you end this, and then you have is equal to this. Left dot. When you integrate, what do you have? Should I write the integral before I evaluate, or I should just put the answer down?
Sir, please.
Should I write the integral?
Sir, please, the x square. You didn't bring the x square.
I didn't bring what?
X square. The integral of from -2 to x square. You evaluate the 16.
Right integral.
You evaluate the 16 minus x square raised to the power 2 minus 3x square raised to the power 2, and you got this, but you didn't attach the x square to it.
Please, if I did not do that, I won't get x to the power 6. Look at this. When you expand this, you get x to the power 4. When you expand this, what do you get? This is giving you minus 9x to the power 4. So if I didn't multiply through with the s square, I won't get x to the power 6.
Oh, okay. Thank you.
So once I have x to the power 6, it means I multiply through all of this. I simplify this. And that's exactly what I did. Please look at it. I have s squared times this minus this before I simplify. That is true. So I believe this answer. I
Okay.
Yes,
use the
sir.
right value.
Okay, sir. Thank you.
Thank
Yeah,
you.
that's correct.
Okay, all right, let's move on. I'm asking if I should I write the answers down, the integral before I evaluate from -2 to 2. I think I'll do that.
The right integral.
8/7, right? X to the power 7. But there's a negative number that I need to keep there. So minus another fraction, 32, but this time over 5. Then x raised to the power 5 plus another fraction, and this fraction is what 256. I like the number 256 because it's useful in computer science. Over 3, because when you integrate s squared, you get s cubed. Good. Then I have to now put this here, right? This. I have -2 up to 2. Let me run this. I'll tell you what the answer is when I'm done using this. Integrate this. I'm integrating from x equal to -2 to 2, and I'm integrating this. Good. 69, 63, 2/105. (105), 69, 63, 2. So one of the things you do is when you pick an example in the book, do it by yourself and compare the answer to it. That tells you you actually understood the material. If you didn't get the answer, you go over it again and check where you've made a mistake. Yeah, so if you integrate this and use the limits, we are expected to get this. 69, 63/2. If we evaluate that, I'm not sure what is. When you evaluate this, what do you get?
Sir.
Yeah, I'm listening.
Sir.
What do you get?
Sir, please.
Yes,
Sir,
I'm
please.
listening. I'm listening.
I've seen a mistake. And I want to
Okay, please.
draw
Please draw our attention to the mistake.
Sir, with after the integration of the y.
Yes.
The -32, is it the x, is it supposed to be to the power 2 or to the power 4?
After the what?
The integration of the y, where you had a -8x to the power 6 minus 32x to the power 4. I'm asking to the power 4, is it 2 or 4?
I have simplified this whole thing. I've simplified this expression.
Okay, sir.
Six, 9, 6, 632. 632 divided by.
That's 60.
69632.
663.16.
Exactly.
663.
What's the answer?
663.16.
69.
663.1619. Thank you.
Yes, sir. That's the correct.
663.1619. Is that what the book has?
Yes.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, so it means we've not made any mistakes. So those of you who think I've made a mistake, please check your work. At least I have the answer that is in the book. Yes, 663.2. So those of you who were feeling I've made a mistake, please, I haven't made any mistake. My answer is confirmed. Please, one thing is this. When I am marking this work, when you do the work and I'm marking, I concentrate on this. So if I have 15 marks to give, I concentrate on this. This alone takes about half of the marks, because once your limits are right, it means that what you have defined the region. What is important to me in this class is that you are able to write the limits of an integral such that integral clearly defines the region of integration. I am not teaching techniques of integration, please. So your final answer depends on whether you understood. This is what is important to me. You writing this limit that, okay, integrate for y, integrate from c to d, and for x, integrate from this y, g of y to h of y. That tells me that you have completely defined the limit of the integration. And that tells me if your work has to do with, you can think about it as, what's it called? For those of you in electrical engineering, you can look at this as the strength of a magnet within this. So the magnetic field within this region. And these integrals have a lot of representation. So it depends on what you are working on and what they represent. For somebody who is interested in what's it called, thermodynamics, this can define the region of heat dissipation, the region where you have certain amount of heat. So you can have heat in what? A cylinder. You can have a heat in a particular object. Now the walls of the object are defined by this curve. And that is what you should be thinking about, that these integrals have a physical meaning. Okay, so we got this graph perfectly done, and this integral is okay. So when I am giving you a problem, I'll definitely say, okay, this integral represents this, obtain this for me, because I want you to be able to relate with it as an engineer. So you don't see math as an abstract thing, but you can see it as a tool for solving a problem somewhere else. Good.
So actually,
Yes.
in case where I will be giving like initially we're never even given the equation. We have to derive the equation from the graph. So in such cases, without using NOPO, I mean we have to use it on a theoretical aspect. So how can we define those graphs out of the question?
I'm missing what's the call? The
What I'm saying
question.
is that initially we're never given a graph. Like we have to plot the graph from the details we're given. So
yes, and that is exactly what I'm trying to look out for. I'm actually going to the exercise to pick up a question which asks you to do something similar. Okay, so this is asking you to sketch the following region and write an iterated integral. So it's actually asking you to write, but that's not what I'm looking for. I'm looking for a complete definition or a word problem where you are supposed to get this. Okay, so let's look at this. The region in the first quadrant bounded by the x-axis and the line this and the curve this. Is this okay? Is this a good question? Does this help you to think about what you're just looking at?
Yes, sir.
I'm asking if this helps. If this helps, then we take it and look at it.
Yes, sir. Yes, sir.
Okay. So you're supposed to, I don't know whether you are evaluating. Let me look at the, it says the region. So let me see, what's the preamble? Okay, write an iterated integral of a continuous function f over the following regions. Okay, so they didn't actually give us a region. So what we'll do is we'll try to find the volume of this region, or we'll find the area bounded by this region, which makes sense. You know what the first quadrant is, right?
Yes, sir.
Thank you. So let me put this question right here. So this is another example.
Joseph.
Please,
Joseph.
let me see if this works out for me. Test. I hope I have color in my, if I don't have color, it might not work out. No, it's not working out that way. I'll check out. I wanted to change the test color. So just test bold font. Come on. My Google Drive is actually interfering with my work. I copy the text. Copy. Exercises the line. I want to be able to see this. X is equal to y minus 6, I think so.
6 minus
6
y.
minus y.
So, so x is equal to 6 minus y.
X is equal to what? 6 minus y.
Yes.
Yeah.
Okay, 6 minus y. Thanks. That means I'm looking at the negatively sloped line. Yeah, negatively sloped line. And the curve is what? Y is equal to square root of
X.
x. Square root of x. Thanks. Okay, so let's look at this and see how we can think through this. What's missing? There's something. Determine the area of the region in the first quadrant bounded by the x-axis, the line, and the curve. This. Oh yeah, I didn't end my equations. Good. Okay, so let's sketch this and see what we get out. As usual, can I just copy this and then change my graphs? Let me copy this and change the functions. I have square root of y, right? So the first one is, I'm rewriting it as what? 6 minus x. That is possible, right? Can I write that function as 6 minus x?
Yes, sir.
Thank you.
Yes, sir.
Square root of x.
But so
Because I'm doing, I will start from 0. Somebody is asking a question.
yes, yes, why 6 minus x?
Why 6 minus x? So somebody
Change
is
of
asking.
subject.
Change of subject.
Are you answered? So let me expand this graph. Good. This is how my line looks. So this is the line what? X equal to 6y. This is that line. This is the curve, the square root of x. And then does this make sense? So this is the region where I'm supposed to work or find the area for. Are we clear with this?
Sir,
Yes.
the subject of the formula is it not supposed to be y x minus 6?
What is yx minus 6?
Like the what you change? You change the subject of formula you changed.
Please, we are doing x is equal to 6 minus y. Can I switch x and y? Can I do this legally and go?
Yes.
Can I write this as y is equal to 6 minus s? Can I do this?
Yes, exactly.
Okay. What I'm saying is, okay.
Yes.
What I was saying is, it should be x minus 6 or minus 6 plus x.
Why?
Changing the subject of the formula.
What is the difference between minus 6, minus x plus 6 and 6 minus x? Is there any difference? Or I am not getting you.
Okay.
Please.
Okay.
No,
It's
sir.
clear.
I'm not getting him. Am I getting him or I'm not getting him?
It's clear. It's clear.
It's clear. It's clear.
Or he doesn't have a question? Which of
Clear. It's
them?
clear. It's clear. It's clear. I got it now.
Thank you. Good. Let's move on. Okay, so this is just in the person. This is not an algebra class, so we are not going to be going over change of subject and those things. This is definitely not an algebra class. This is a high-level calculus class. Thank you. So let's look at the region. We've been told that we are interested in the area bounded by the first quadrant, the x-axis, the region in the first quadrant, the x-axis, the line this, and the curve this. So we will have to define exactly where we want to stay. Now let's go to our graph. This is the first quadrant right here. This is first quadrant. In the first quadrant, x is positive, y is positive. So we are in this region. Then we are looking at the region bounded by this line, this curve, and the x-axis. So we are in this region. Do we all agree this is where we have to stay?
Yes, sir. Yes, sir.
Yes, sir.
Thank you. Thank you. Now let's look at this and see how we want to. I think I'll have to copy this graph and put it into my, what's it called? Inkscape and do. But let's look at something. Now, how do I write the limit of this? How do I write this limit? Let's think about, because this is what this class is about anyway. How do you write this limit? So you can actually define the exact region. How do you do this? Who can tell us what they think?
Sir,
Yes.
sir, I suppose it will be on 0 to 6 on the x.
0 to 6 on the x, I agree. And then the y?
And the y is going to be the x. Wow.
So the y will be 0 to 2.
Y should be 0 to 2, I agree.
Yes.
And then x will be?
And x
0
will
to
be
6.
0 to 6.
That becomes a rectangle. You just told me I should start from 0 to 2 and then 0 to 6. That becomes a rectangle. Look at it. You have a rectangle. 6, 2. This is a rectangle. You have included regions we don't want.
Say that will be from 0 to 4. And 1 will be from 0 to
Which one is from 0 to 4? Which one is 0 to 4?
x.
X will be from 0 to where?
4.
0 to where?
4.
4. Okay.
Yes.
If x is from 0 to 4, I agree. Y will be from where?
0
Y will be from where?
0 to 2.
0 to what? 2.
2.
If you do that, this is what you have. Yeah, 2. This is 2, right? This is the value. This is 2. You are saying 0 to 2 and then 0 to 4. You have included this region. You have still made a rectangle.
Sir,
Please,
sir,
this is general region, so don't give me rectangles. Thank you.
sir.
Speak.
Sir, I think the y is going to be 0 to y squared plus y minus 6.
Okay, so you're thinking about, why do we have y squared plus y minus 6? Where did we get the square from?
Sir, I actually equated the line and the curve as an x
Oh,
equals to 6
you are
minus y.
finding this, you wanted to solve. Okay, so let's look at this. Let's look at something. The one who said we should start from 0 to 2, that is perfect. You can start from 0 to 2, but if you do that for y, then x must be from where? This curve, this curve. So these are the possibilities. I'm going to type it out now. Then along the x-axis, I'm going to have y squared less or equal to x less or equal to 6 minus y. So this or this, I either have zero less or equal to x less or equal to 4 quad. So I'm looking at the graph for this. If I move from 0 to 4, assuming this point, the point of intersection, has somebody solved it? Is it actually 4? I can actually solve that anyway. So I can actually solve this. I don't know why this keeps bothering me. I can solve 6 minus x is equal to square root of x for the value of x. I can solve this. Yeah, it's 4, so that is perfect. If I solve that, I get 4. So this is 4. So 0 to 4 for this, but then the y must change. 0 less or equal to y less or equal to hold on this. Less or equal to square root of x copy this from 4 to 6. 4 to 6 and 0, but this time I have what? Move. I'm going to make the line 6 minus. Okay, let me explain this. I have this now, and I'm going to leave the work for you to do. Do the integral and compare the answers. Something is not right somewhere. I'm looking for L less or equal to. There's another one. L less or equal to. So my problems are not over yet. Good. All right, so let's look at this. I'm looking at this. We may either have this. We have the limit of the integral from 0 to 2 for y, and x will be between this. So please look at the graph carefully. Now I have to explain what I'm Good. This is fine. So along the y-axis, I'll start from 0 and get to 2. This is okay, right? You've accepted this.
Yes,
Hello?
yes, sir.
Yes, sir.
So along
Yes,
the
sir.
y-axis, I'll start from 0 and end at 2. But along the x-axis, you cannot start from 0 to 6. That will make a rectangle. But you start from this line. This line, which is written as what? Y is equal to square root of x, can also be written as what? Y squared is equal to x. That is possible. So I'm looking at this. Y squared is equal to x. I can do that. So I'll start from this line and end on this line. So if we are moving, you start from this line and end here. That is true. So you either do it this way from 0 to 2 and from this line to this line, this curve to this line to define your area, or you look at the other one and you split the region into 2. The other one is I'll split the region into 2 from 0 to 4. That is right here. So I've drawn a line. There's a line that I'm drawing here. 0 to 4. And if I do from 0 to 4, this is x is from 0 to 4. Then the y-axis will start from where? The x-axis is the same as what the line y equals 0 line. So along the y-axis, I'll start from 0 and end at the square root of x. So I've divided the region into 2. Then there's a, what's it called? This triangle section left. So I've done this, and then I must also do this and add the 2 of them. So I'll do 0 to 4 and then 4 to 6. But 4 to 6, this time along the y-axis, I'll start from the line y equals 0, and then I'll end at where? The line 6 minus x. And as a matter of fact, if you do these two integrals, the result you get will be equal to if you do that one integral. You get this. So we are going to do this and get the value for my class. We'll do it now. You spare me some few minutes. I know you don't have any lecture after my class, but don't worry, I will still know. If I give you too much, it will be a lot of work. So you can have this. I'm doing this, then I leave this one for you to go and do. And compare. You must do this plus this to get that answer. So we'll do this one and then you do the other one when you are learning. Good.
Sir.
Please speak.
Sir, I have a question.
Please speak. I said speak.
Okay, sir, concerning the two integrals we have here, sir, can we join them and
Yes.
say for the x it's going to be 0 less than or equal to x less than or equal to 6, then 0 less than or equal to y less than or equal to 6 minus x.
Please try it. Please try it. Please try it, okay? Just try your limit and see whether you get the same result. And then use this and see whether you're learning. So this is the time to explore. And I want you to cultivate this habit of exploring. I went to class, the lecturer explained it this way. I want to explore if there are other ways of getting it done. And I encourage my students to explore.
Yes, sir.
If you don't get it, it means there's something not right. So explore so you can find out what is working and what is not working. Thank you. Which one am I doing? I'm doing the integral from 0 to, this is the same as integrate from 0 to 2, and then integrate going out. And then integrate, I have y squared. Um, 6 minus y. So I'll integrate with x first before I integrate with y. But I need this. Something is not right. I need this. So that it becomes an integral from 0 to 2. And then I have the function. So if I do this, I have the function with bracket 6 minus y squared dy. Perfect. And then I'll have 6. When I do this, I have 6y minus y squared over 2 over 2 minus y cubed over 3. So this is for this. Then I have right evaluated with 0 all the way to 2 to prevent you from screaming at me. I have this. Okay. Good. So I have something that looks like this. This is perfect. 6y minus y squared over 2 minus this, and then I have this. So I can evaluate this with respect to 2, and then I get an answer. So to do that, I'm basically just going to evaluate this in Maple somewhere and put my answer down. So I'm integrating 6 minus y squared. I'm integrating y starting from 0 up to 2, close bracket, evaluate 22 over 3.
over 3.
Yes. Thank you. Perfect. Perfect. So now your responsibility is this: do this integral and do this, sum the two integrals. These two integrals, when you sum them, you should get this result. I'm going to, let me put this in a box. Oh, box. Okay, so I'm doing this. Or the union of the or the union of this. Copy. So basically, I'm trying to just format this. So I'm doing a formatting for you, something that what I'm trying to do here is basically just formatting. Begin array. Left. And array. Okay, so let me see if this works out well for me. Still, it's not working. Okay, so the union of this. Sorry, I'm not sure what's wrong with my boxing. I wanted to put them in a box. It's not working. So, good.
Hello. Yeah, you were class.
Okay, all right, so I have this. Now, what I need you to do is, has somebody done the work already? Hello? Hello?
Yes,
Yes,
sir.
sir.
Has somebody done this integral with the limits? Has somebody done this?
Yo. Oh, no, no, no. Which one?
Oh, no one has done this. I thought you'd have been working on it while I'm struggling with my typing. So integrate, this means that you integrate with y first before x, integrate with, and then this. So let me type out. I can do this. We have the limits of the integral to be either this hence we have this, or anybody has an integral, just do one of them. Hence we have this. So copy. So I'm looking at this over the entire region becomes, anybody has something?
Sir,
Yes, yes, I'm here.
yes, sir. I did the tail one with the bound 0 is less than or equal to y and y less than or equal to
Sorry, your line
6
is
minus
your line is
x.
breaking. I can hardly hear you.
Yes, sir. I did the last bound,
Okay.
which is from 4 6 on the x-axis, and I did the answer. I got 2 as the square unit. And my final answer for the area under the curve is 28 or 3.
28.
28 or 3.
28 over 3.
Yes. As the final answer, as the final area under the curve.
I don't agree.
1030. It's not the integral of this one. The integral of this one I got 2. But then when you sum the integral of the first area and the next, that's how I got 28 or 3.
Please don't worry. I'm just trying something. So I'm editing something and then I'll let you know what I'm working on. Good. So this is what I'm working on. Dy dx. So if I do dy dx, in this case, this becomes 0 to 4. Becomes 0 to 4, and then I have square root of x to do. Square root of x to integrate. but I also have this plus this. Four to six, and then this becomes what? 6 minus x.
Sir.
Yes, please just
Sir.
give me a few minutes. I'll explain something. Yes, please. Give me a few minutes. I'm trying to just pull out something. Okay, so let's look at this. If we use, okay, now you can ask your question before I go on explaining.
Sir,
Someone told me. Yes.
Yeah, I was saying that I've solved both of them. I had a 22 on 3.
Thank you. I expect that, honestly speaking. So that is exactly what I'm working on now. So the first one is this. I'll use this. So this is how you use the limit. 0 to 4, then 0 to the square root of y. So 0 to 4 for the x-axis, then 0 to y for the y-axis. So when you do the y integral, you have this. You put in square root of this minus 0. So you have this to do with respect to x. Then you integrate with respect to y. You have 6 minus x minus this. And then you do this integral now. You integrate with respect to x. And then you put in the limit. So we're going to do that. And then you see what the result will be. I expect
so
you to get
it will be the same. 22 on 3.
22 over 3.
Yes, sir.
Thank you.
The
So
first
I'm
one
not
is 16 on 3, and the second one will be 2.
So I'm getting your results as the first one is
16 on 3.
16 on 3.
And the second one is
6 over 3.
Yes,
plus 2.
Plus
yes.
2.
Over 3. Thank you.
Yes, yes.
Did I get it right? So 16 over 3 plus 2, right?
Yes.
So you have the 22 over. Thank you.
Yes, sir.
Yes, sir.
Thank you. So I have basically covered double integrals, and I have discussed the order. So if you look at this, the first integral, we did it with respect to x. So you do x.
Yes.
Is somebody speaking? Should I check my? Okay, there's chat messages that I haven't read. Okay, few of them. Let me go over that. Sir, please, 3 colleagues have been denied access to the class. I'm not sure what you mean by 3 colleagues have been denied access to the class. They cannot be denied access to the class if they are using RMU email. If they are not using RMU email, I don't have a problem with that, because everybody is supposed to use RMU email to join the class. So if you are denying access, it means you're not using the right means to join the class. Okay, am I the only one who can't hear a word? Oluwatobi, I don't know if your problem is resolved. Is your problem resolved? That was about an hour ago. I had no idea you left a message here.
Yes, yes, it was my network.
Good.
It was a network problem.
Okay.
It was a network problem.
Okay. Are we going to get this note after the class? Yes, you will get the note after the class. I will actually upload my slides. So whatever I've done, I'll put it in a slide form and upload it for you. So you're definitely getting a slide.
So that will be very, very
I am asking myself the same question. That was a very silly comment to make on a class platform. Please, if you don't have a question, don't put silly chats on this. I don't have time for this one. No, I'm serious.
Yes, sir. Yes, sir.
Good. There's nothing else there. And I said that. I said I'm taking you through the textbook. I'm going section by section in the textbook, but I'll give a summarized note. I'll upload a summarized note to the Google Classroom. I did say that.
Yes, sir, you did.
If you're sitting in front of me in the lecture hall, I'll just come and go through this without projecting the textbook for you, because I would have written whatever I need to write out of the textbook and come and write it on the board, and you copy notes and go away. Here am I typing while I teach, using lec2 to type while I teach. You can see I have to write a script and run it for you to see what I'm working on. This online class gives me a lot of work to do, more than it gives you to do. That is a fact. Because it would have been easier for me to use a marker and write this on the board and go away.
Yes, sir. Thank you, sir. We actually appreciate your efforts.
Okay, where are we? Good. Not much to be said again. This can easily be done, and then the result is. What is important for me at the end of this class is that I've covered double integrals over general regions, and I have used 2 examples to explain how you can write the region. Fortunately, I got one example where I can actually split the domain or the region into 2. You can divide it and then integrate. So if you look carefully, I integrated from 0 to 4 and then 4 to 6. 0 to 4, 4 to 6. But then the y's change from 0 to this and then 0 to this, because I have different curves intersecting at a point. And this helps me to be able to do the integral and get the same region. So the one who asked the other question, whether you can integrate from 0 to 6 and then y from this, please go and try that and see if you get the same answer. If you don't get the same answer, it means that it's not the same. Good. The last
I tried it, but I didn't get the same answer.
Then it means that it is not a right, and that is how, when I am marking, my emphasis is on the limits you write down. Because if the limits are wrong, you are not working within the specified region. Okay, the last thing I need to do under double integral is, if you are working in a circular region, that is polar coordinates. And that will be in section, I think, double integral, section 14.3. So in polar coordinates. This is important because you may have to deal with a circular object, like working in a cylinder or working in, what's it called? A circle of a certain radius. So I have covered the rectangle, I have covered the general region, and I'm going to deal with polar coordinates. But I will not do it today. I'll do it on, okay, so now let's agree. Something happened on Monday. Let's agree on this. We've agreed that we will go by the timetable. Was that not what we agreed on Monday?
Yes, sir.
Good. So please, network is not an issue here. We'll go with the timetable. We'll have the lecture from 5 to 6:40 on Mondays. p.m.
Yes, sir.
So whether you have network issues or whatever it is, I will still hold my lectures. So it means on Monday, I am covering this.
Okay.
You can go through it before the class so you can ask the required questions. Because if you've gone through before I'm teaching, it helps you to understand. No, good. Before I end today's section. Is there anything I need to know before I end today's section?
No, sir.
No, sir.
Okay, all right. So good luck. And I encourage you to try all these questions. I encourage you to try the questions. Some of them will come with different techniques of integration. A typical example is if you look at question 96, if you have to do this integral, you have to use what? Partial fractions.
Yes.
Some of them will come and you also have to use, you first of all decompose, and you may have to use trig substitutions, because this looks like 1 over 1 plus y squared, which becomes tan inverse of y. So you employ all the techniques of integration, but my main goal with this class is that I would define a situation for you, and you're supposed to define the limit which gives you that integral. So try problems in the book. If you have anything, you come to class, you can bring it out and we'll do. You don't have a TA, so you won't have a tutorial section. So my class, if you come with problems, I'll answer them for you. I'm getting a feedback. Somebody's microphone is giving us feedback. I can hear my feedback from somebody else's microphone. Okay, anything else I need to know? Is there anything that I need to know?
Sir.
Okay, so I'll upload the
No, sir.
the work I did today on the
Handouts.
yes on the Google Classroom platform. Please, if you still do not have RMU email, please send an email to the IT for support. You need IT support, and you have to get that from there. I don't give out